Okay, so we're going to talk about the one-to-one property of exponents. Basically, if we just kind of take a look and see what's going on here, we have this guy right here, and some base raised to an exponent, and some other base raised to another exponent. Well, b is the same number, so then that means if b is equal to this guy, then their exponents must also equal each other. So let's do a quick example. If we had, I don't know, 4 squared is equal to 4 to the y, then we know that in order for these guys to be equal to each other, y has got to equal 2. That's basically what this property is telling us. Now let's just do a couple examples here. So there's a couple different examples, and so we're going to find the value of v, and we're going to apply. We're going to apply this one-to-one property. Okay, and this guy was in exponential form. So if we look at this guy, this isn't in exponential form. It makes it a lot easier to look at this. So I'm going to do a little spiral thingy. We'll always go towards the equal sign, and so 4 to the v is equal to 64. So what actually does v equal? Some of us would be able to have some intuition here and know that v is this value. Well, what we want to do is we want to break down 64 so it's written as a power of 4. Well, maybe we can't do that, and we'll see. I know 64 is the same as 8 squared, right? 8 squared, 8. 8's 4 times 2. Hey, 8 is the same as 2 cubed. Okay? So that means 2 cubed raised to the second power is the same as 64. And this falls back onto our exponent properties. Well, I could write 4 as a power of 2. So I'm basically taking these terms and rewriting them as powers of the same base. So now that we have the same base, we can apply that one-to-one property, but now I have to simplify my exponents a little bit. I have 2 raised to the 2v is equal to, and then these guys get multiplied. 2v is equal to 6, so v has to equal 3. Some of us might know that v is equal to 3 by looking at it, and that's fine, but if we had to break it down and have some sort of process to go through to find that number, that's what we would come up with. Here's our next example, find the value of v. I'm going to go ahead and I'm going to rewrite it in exponential form. V to the 4th power is 16. So with this one, we kind of have to work backwards a little bit. We want to know what the base would have to be. So 16 is the same as 4 squared. 4 squared, okay, so 4 is the same as 2 squared raised to the second power. So v to the 4th is equal to 2 to the 4th. Hey, they got the same exponent. What does v have to equal? 2. And that's how we got to go through these types of problems. Next one we have is log base 5 of 1 over 25. This clue right here, this fraction, that should tell you I'm dealing with a negative exponent. Okay? So I'm going to go ahead and rewrite it in exponential form. I do a little spiral thingy, so just a little bit of review. 1, 2, 3, right? So it's 5 to the v power is equal to 1 over 25. So in order to get these guys to the same base, let me shrink this one a little bit. I know that 25 is the same as 5 squared, okay? But in order for me to have it as the same base, I need to flip it up to the top, which makes that a negative 2. Now I have the same base. V is equal to negative 2. 16 to what power is equal to 2? Okay, so that means I'm going from a larger number to a smaller number, and the exponent here is 1. So what I want to do is I want to get them to be the same base. I should expect that v is going to be a fraction because I'm getting to a smaller number from 16. Okay, so v is going to be a fraction. So, well, I know 16 is 4 squared, right? 4 is 2 squared, right? And that's equal to 2 to the first, right? And then I got this v on the outside. So I know 16 is the same as 2 to the 4th power, and then we got v raised to the v. So I know I got 4v is equal to 1. So I just set the exponents equal to each other, and v is equal to 1/4. This is our last example. 27 what power is equal to 3? Once again, I'm going to reduce the base. I got 1 as this exponent. 27 is the same as 3 cubed. That's one that you should definitely know. 3 times v. Let me erase this real quick. And it's 3 to the first, so I take my exponents and equal them. 3 to the v is equal to 1. V is equal to 1/3. And that is how we can use this one-to-one property, get same bases, and then solve for our exponents.